So there are many definitions for force what we study in higher classes. Now the simple definition we can give for force is a force is a push or pull on an object. At the same time, a force can change the shape of an object. A force can change the shape of an object. When we take an elastic substance or spring and compress it, we can see the shape of the object is changing. The force can easily change, but always when a rigid object, you know to change its shape. So that is what we say, it can change. It is not a must thing, it can change the shape of an object. A force can increase or decrease the speed of an object. And it can stop a moving object. So a force can, or a simple definition for a force is a push or pull on an object. What changes a force can make on an object? We can see a force can change the shape of an object. It can start motion on an object. It can also stop a moving object. At the same time, it can increase or decrease the velocity or the speed of an object. So this is about the force. Okay, so I think you already noted this one. So you can use your last year book, last year running note physics book, or else you can give a new book, small books for all these notes. And here I give you a summary of this one, not the complete one. In this one, we can understand if the question is what is a force. We can define the first line is the definition. A force is a push or pull of an object. In 8th class, if you write that one, we get the full mark. It is a pushing force or a pulling force. We push a door to close it. We pull a door to open it. So this all will come under force definition. And what are these? What are the changes that a force can make or do on an object? Means if we press an object by applying a force, we can change the shape of an object. We can increase or we can decrease a moving car or a moving bus. How the bus is coming to stop or coming, how you can increase or decrease the speed of a cycle when you are using a cycle. We increase the force to increase the speed. At the same time, we can decrease the force to decrease the speed of the object. And to stop the running cycle, we need to apply a brake. That is nothing but a force. So by applying a force, we can stop a moving object. At the same time, when an object is at rest, to move that object or to make or to create a motion on the object, we require a force. So these are the things a force can do on an object. Now, let us see the different types of forces. Different type of force. Mainly we can divide this force into two groups. One is contact forces. First group, contact forces. Second one, force at a distance. Force at a distance or field forces. Contact forces or force at a distance or field forces. And what are contact forces? Some examples I will write. Muscular force, friction, normal force, tension. All these are the example for contact forces. And non-contact force example we can see magnetic forces, electrostatic forces, gravitational force. So first one is the different types of force. First one is, I'll give you time to write once. Let me explain. Contact force, and another one is forces at a distance or field forces. What is a contact force? Contact force means by direct contact of the objects. Muscular force, in contact forces, the two objects are in contact, or who applying the force. When I am applying the force and me and the body is in contact, there is a direct contact between these two objects. That is called a contact force. In that, one is muscular force or machine force or applied force, we will say. Muscular force means this is also called a applied force. Applied force. So what kind of forces which are in contact? And another one example for contact force is friction. Friction. Friction is a force which is opposing the relative motion of two objects, or the force which opposes the relative motion of two objects is called friction. Because of the friction only we are able to walk. Because of the friction only I am able to write on the board, because there is a force which opposes, otherwise it is skill. And next is normal force and tension. I'll explain one by one this one again. First, you can note down these examples. These are the examples for contact forces, and they are muscular force, frictional force or friction, normal force, and tension. And at the same time, one is force at a distance. Force at a distance means these two objects are not in contact. There is a distance between, the distance is very small or big in material. There is a distance between these objects. The objects are not in contact. There is no direct interaction between these objects. They are also called field forces. So for example, for field forces is magnetic force, electrostatic force, and gravitational force. So you can note down this one: contact forces and non-contact forces. Children, please do not write over this one. Huh? If you write this one, it is not clear. Please just listen here. Students, please don't write here. Somebody is writing. So here you can see this. This is actually for, you can copy this one, not a. So contact force. Okay, see the definition for contact force. A force that can cause or change motion of an object by touching it, by a direct contact. So motors and gears operate through contact forces. So this is the this is the definition for contact force. Example for contact force is also, you can see here, that is friction, normal force, air resistance, applied force or muscular force. These all are examples for contact force. And again you can see this side, non-contact force. Force that result when two objects are, please children, students, please do not write on this one. Please erase it. You just listen and this is writing. So example for and definition of non-contact force. Contact forces means the force that can cause or change motion of an object by touching it. You please note down these points. This is the definition for, or what is contact force. This is the answer. And here you can see the example for contact force and non-contact force. Force that result when the two objects are not in physical contact. Actually, when the field force or non-contact force or force at a distance, all are same. We studied now 3 points about this one. Non-contact force is also called forces at a distance or field forces. And gravitational force, electrical force, and magnetic force are example for non-contact forces. Anjana Sai, what is your doubt?
Sir, what is the meaning of air resistance?
Air resistance means, see, when you keep or when you drop a small stone, what happens? It falls down very quickly, isn't it? At the same time, suppose you are dropping a feather or a paper sheet, what happens?
It will fall very slowly, sir.
Yes, it falls slowly. Why it falls slowly?
Because it is very light, sir.
Because it is very light, not the reason. Because it is affected more by the resistance or friction of air. Understand?
Yes, sir.
So because it travels through the air, air opposes a force. That opposing force is called what? What is the opposing force is called? Frictional force, okay? Still doubt, huh? Rama, what is your doubt?
Sir, what is tension, sir?
What is?
Tension.
For tension, okay. All these points one by one I will explain, okay?
Thank you, sir.
This is first we are explaining about the contact force. And then what is muscular force, what is frictional force, what is normal force, what is tension. One by one we will explain, okay? Manohar. Manohar, I can't hear you. Say. Manohar, I can. Okay, please say. Manohar, your voice is not audible.
Sir.
Hello?
Sir.
Yes, please say.
No, sir.
Huh?
No doubt, sir.
No doubt. Okay. Then don't raise your hand. Okay. Let us now see. So we already wrote here. So now one by one we can explain. You asked some doubt. What is the meaning of friction, normal force, and tension? One by one I am going to explain it. After completing this contact force, we will go to second topic, that is force at a distance. So only now just I say the names. What is magnetic force? Again we will explain. We are going to study magnetic force is a non-contact force, and electrostatic force is also a field force, gravitational force. Don't worry about all these one by one. We are going to explain all these one. First, let us explain what are the examples of contact force. Hima.
Sir,
Yes.
is force at a distance or contact for it?
Okay, no problem. Ask. Complete your doubt. Okay, understood. What is your doubt? I think you are going to ask force at a distance are also contact forces. Okay, so force at a distance means what? A contact force means what? I already explained. A contact force means there is a direct contact between two objects. So force at a distance means there is no direct contact. There is a distance between these two objects. So force at a distance is not a contact forces. Now let us come to this. Okay, Gopal. Gopal.
Sir?
Yes.
Before you open one page now, sir.
Okay.
Can you give that back page, sir? I didn't note it fully. Just I wrote the. Just
Okay,
I noted.
before the end of the class again I will give you. Okay.
Okay, sir.
Okay, again I will show you. I will give you what that is. Okay, this page I think you want. Please note down, or others also. If you are not noting it down, it is the here the examples are there, definitions also there. Yes. I said you the beginning of the class. You keep a notebook with you, not a rough notebook. What we used in 8th class, if balance page is there, you can use, not a problem. Otherwise, you can use another small book. After the reopening, your teachers will check all these notes, because we are giving you very less short note only. Pavia.
Contact force, sir. Definition.
Contact force definition. You can see on the screen. See, a force that cause or change motion of an object by touching it, or else you can write by the direct contact between two objects.
Sir, tell once again, sir.
Okay. A force that can cause or change motion of an object by a direct contact between the object. A force that can cause or change motion of an object by direct contact between the objects.
Okay, sir.
Okay. And you can note down, see, can you see the examples here? Manoj. Bala.
Sir,
Yes.
in force at a distance, what is the second force name, sir?
Here on the board I wrote down. First one is magnetic force.
Yes, sir.
Second one is electric force or electrostatic force. Electric. See the board again. The board you can see here the screen you can see. Electric force. Second one. First one is magnetic force.
Okay, sir.
Second one is electric force. Third one is gravitational force.
Okay, sir. Thank you, sir.
Okay. And here you can see the type of contact forces also. Okay. Now I said we study about this one by one. What is muscular force? Muscular force, we know, the force which is applied by human beings, animals, and machines, all will come under muscular force. What we do with our hand, pushing or taking a bag, taking a bucket of water, carrying some objects from here to there, all this comes under muscular force. Today, what is your task is, all the listen children. Today, some examples I gave you. Today, what you have to do is, you can take a new page and you can write this heading. You have to write only 5 examples for each. For example, you are writing muscular force. 5 examples like this. First one. What is the example for? Muscular force. Carrying my bag to school. Like that. Okay, Surya Prakash, what is your doubt?
Sir,
Yes.
what is muscular force? Can you tell again, sir?
Yes, that is what I am explaining. I started already now. Okay, the force.
Yes, sir. Sorry, sir.
Okay, no problem. Okay, the force what? Human beings, animals, and it is also called a applied force. So applied by any machines also called what? Muscular force. So now what you have to do today is, I said you write 5 examples for muscular force. What the work you are doing, you can write very simply. What the work you are doing? If you are carrying a bag from home to your school or taking a bucket of water, all this will come under water muscular force. Like that, you should write 5 examples.
Okay, sir.
Okay, for all children, all children. So muscular definition, no need, definition already I said you, no need, only examples you have to write. Muscular force. Next one is, second one is muscular force. We know muscular force is, once you think contact or non-contact force, muscular force, it is a contact force. Why? Because our muscles have no more attraction. We have to carry it by touching it. We should push it or we have to pull it. All this one, push or pull, all this will come under muscular force. Otherwise, if there is a no direct contact or interaction between the object will not move. So muscular force is an example for contact force. And again, you have to write example for this one is what? Second one is friction. So already some students asked here. The friction means the force which opposes the relative motion of an object. The movement of an object, that is called frictional force. When you roll a 1 rupee coin on here, you can see it stops. When you throw a stone, It will not continue its journey for a long time. Before that, it stops because air resistance, the friction offered by the air. So that is friction. And again, next force is, so many asked, what is normal force? What is normal force? So today we study about what is normal force, and tension we can see next class. What is the meaning of normal force? Kumari. Okay, Kumari, what is your doubt? Madam, they are sharing screen. Kumari, say your doubt. Okay, let us continue. This name? Name?
Hello, sir.
Surya.
Yes, sir. What is the
Yes.
meaning of normal force, sir?
What is the meaning of?
Normal force, sir.
Yes, normal force is our next topic. Tomorrow I will explain. Today our time is going to complete now.
Yes, sir. Thank you, sir.
Today you study only two forces. What is the two? What I study today is one is muscular force, another one is friction. Okay. So normal force and tension we explain tomorrow. Asrita.
Sir,
Yes.
what? Please tell me again frictional force
Okay. Listen.
definition.
Okay, listen. The force which opposes the relative motion of an object is called the force which opposes or stops. No need to stop, it can even decrease. The force which opposes the relative motion of an object is called frictional force.
Thank you, sir.
Okay. So you should write examples. Okay, you can write now. Still anybody want? Okay, so how many students? Okay, remaining students doubt tomorrow we will clarify, because today we are going to end up this session. Okay, all of you have doubt means you can write on your the book itself what is your doubt, and next class again you can ask. We will continue this classes. Okay, so no need to worry about all of your doubt. So today only two small things I said you. What is the two thing is you should write 5 examples for that two contact forces for muscular force and frictional force. 5 examples. Just taking you write 1, 2, 3, 4, 5 like this. 5 examples you can write. And tomorrow or after when the school is reopening, keep your date. What is the date today? Pick the date and that day's homework or assignments you can write. So like that, or else it is the date and day 1. Today is our first physics class. Day 1 and date and today's homework. So it will be very easy once you reopening, and have a nice day.
Okay, good afternoon, children. I am Sachinarayana, Faculty of Mathematics. Yesterday, I explained about number system. Means that is natural numbers, whole numbers, integers, later rational numbers. Yes, yesterday I explained about these things: natural numbers, whole numbers, integers, and rational numbers. Today we are going to learn about more on rational numbers. Okay. So to see, children, all of you look at the board. Rational numbers means this is natural numbers, these are whole numbers, and integers. These are all numbers included. Natural numbers. Every natural number is whole number. Every whole number is integer. Yes. Here, every integer is a rational number. Every integer is a rational number. Natural numbers means 1, 2, and so like this. Into whole numbers means including 0 whole numbers. And here again negative numbers -1, -2. Here 1, 2, 0, -1, -2 up to these are integers. And the extra numbers you can add here. Rational numbers means yesterday I explained about this one. The numbers which can be written in the form of p by q, where p comma q belongs to z and q not equal to 0 are called rational numbers. Means -2 by 3, 0.5, 8 by 7, like this. These are rational numbers. Why? Because 0.5 is a rational number, means it can be written as 5 by 10. Because the point after one digit is there, here this is decimal number, it can be written as 5 by 10. So 0.5 can be written in the form of p by q. Can be written in the form of p by q. So here it can be, it is also a rational number. Yes, natural numbers, whole numbers, integers, and rational numbers. Now, see children once, here rational numbers can be written as we have one rule, that is the set builder form. How to write this one? Q is equal to, Q means quotient numbers. Quotient numbers means rational numbers. We know yesterday I explained about this one. Rational numbers also known as quotient numbers. That's why rational numbers are represented by capital Q. Here it can be read as x such that x means it can be read as such that x such that x is equal to p by q, where p comma q belongs to z. Yesterday I explained about this symbol belongs to, means these two p and q can be taken from the set z. Z means set of integers. Okay, natural numbers, whole numbers, and negative numbers. Along all of these numbers are called integers. Means p comma q belongs to z, and q not equal to 0. Q not equal to 0. This is the set builder form of set of rational numbers. Yes, children, just write this one: natural numbers, whole numbers, integers, and rational numbers. And write this also. Okay, children. Okay. Today we are going to learn about properties of rational numbers. What about properties of rational numbers? We have some properties. First one, closure property. Second one, commutative property. Commutative property. Third one, associative property. Associative property. Next, distributive property. Yes, children, once look at the board, closure property. Second one is commutative property. Next one is associative property. Next one is distributive property. Still we have some more properties. Those are, see, existence of inverse, existence of identity, existence of inverse and existence of identity. Okay. Now, children once closure property, commutative property, associative property, distributive property, existence of inverse, existence of identity. Okay, children. Now, one by one, I will explain. Listen carefully and write neatly. Okay. Now, in children one, okay. Now, I will explain about closure property. Now, see children, we are discussing about rational numbers now. Rational numbers means Q. Q is equal to set of all the numbers we can, whatever the number, those number is a rational number. 2 by 3, 5 by 7, minus 8, minus 6 by 11, 0.3. These are so and so 0, everything. If those are rational numbers, every number is a rational number. Not irrational numbers, we are talking about only rational numbers. Set of rational 2 by 3, 5 by 7, minus 8, minus 6 by 11, 0.3. Those are rational numbers. Whatever the number we can take here, rational numbers. Close. We are discussing about closure property. Closure property means suppose we can take any two rational numbers from this set. Any two rational numbers from this set means suppose we can take two rational numbers. For example, see 2 by 3 and 7 by 2. 2 by 3 and 7 by 2. These two are rational numbers. Belongs to Q. We are taking from this set Q, set of rational numbers. Now we have closure property. We have four fundamental operations now. What is that one? First one is the from the four fundamental operations. First one, addition we can take. Okay, addition means take these two rational numbers and add these two rational numbers. 2 by 3 plus 7 by 2. We know in lower classes we learned about these fractions. Means unlike fractions means different denominators. 2 by 3, 7 by 2. Here denominator 3, here denominator 2. So these two are unlike fractions. Whenever unlike fractions given, how can we add? Do you know? Just once again I will explain about this one. See, 3, 2, different denominators present. Whenever different denominators presented, we have to find the LCM of these denominator. 3 comma 2. Here see, 3, 2 means these two are consecutive numbers. Means here these are co-prime numbers. What is the LCM of co-prime numbers? LCM of co-prime numbers is LCM of co-prime numbers is their product. LCM of co-prime numbers is their product. Here 3 comma 2, these two are co-prime numbers. Yes. So first we have to change into like fractions. Whenever we want to add the unlike fractions, first we have to change these like fractions, unlike fractions into like fractions. Okay. In up to 5th class, we learned about very well about these additions and subtractions, about unlike fractions. Okay. Now we are 8th class now. So we can do like this. LCM of these two numbers is 6 because of 3 2s are 6. LCM of co-prime numbers is their product now 3 2s are 6. Now LCM is 6. Here see children, here what is the denominator? 3. 3 how many times divisible by 6 here? 3 2 times cancel here. So 3 2 times cancel. Here already numerator 2 is there. 2 2s are 4 plus. Here 2 how many times here? 2 3 times cancel here. So 3 7s are 21. We can add 4 plus 21 how much? 25 by 6. Yes. Unlike whenever unlike fractions given in this way, we can add these two. Otherwise, another method is there. Suppose 2 by 3, 7 by 2 is there. Here LCM of the denominator is 6. We can do like this. 2 by 3 into both numerator and denominator is multiplying with the LCM. 3 table 2 times cancel here. No need of cancelling these two. Just 3 table 2 times cancel here. 2 2s are 4, 1 6 are 6. Okay, keep in mind this one. Next, take 7 by 2. Again, 7 by 2, both numerator and denominator is multiplying with this LCM. Means 6 by 6. Again, 2 table 3 times cancel, 2 table 1 time cancel. Let's see multiplication. 7 3s are 21 by 1 6 are 6. Now 4 by 6, 21 by 6. Means here 2 by 3 becomes 4 by 6, 7 by 2 becomes 21 by 6. Here these two are like fractions. Means same denominator 6 6. Now we can add these two 4 by 6 and 21 by 6. So directly I did here. Understood children? Already you know very well about these fractions, how to add these type of unlike fractions in lower classes. Okay, just okay. If you have any doubt, just once see here, observe once again. Suppose directly we can do whenever denominator is different, we have to find the LCM of their denominators and write LCM as denominator and cancel the first denominator with 3, 2 times cancel here. So already numerator 2 is there. 2 2s are 4 plus 2 table how many times divisible by 6 here? 3 times. Now numerator 7. 3 7 are 21. So 4 plus 21, 25 by 6. Like this. Otherwise, we can do like this also. 2 by 3 into here LCM 6 now. Both numerator and denominator is multiplying with that LCM. Here 3 table 2 times cancel. 3 table 1 time. Okay. Now 2 2s are 4 by 6. 7 by 2 you can take next fraction. Both numerator and denominator is multiplying with again LCM. LCM is 6. So 2 table 1 time, 2 table 3 times. 7 3s are 21 by 6. Like we have like this, we have to change like unlike fractions into like fractions. After changing the unlike fractions into like fractions, we have to add these two. Same denominators now 4 plus 21, 25. Same denominators means we have to write only one denominator. Now we can get 25 by 6. See 4 by 6 plus 21 by 6 means same denominator means we can take one denominator here. 4 plus 21 by 6. 25 by 6 like this also can do it. Understood children? Now directly we can follow like this also. Clear? Okay. Now see. Why we did like this here? This is the 25 by 6. Here 20. Hi Lakshmi. Any doubt?
Sir,
Yes, ask me, Amma.
yesterday you told for rational numbers are also known as quotient numbers.
Yes.
We can represent the quotient numbers also as capital R.
No, Amma.
Only represent.
Only rational numbers are represented by Q only. Because of rational numbers represented by Q, R is the representing number for real numbers. Real numbers are represented by R. Okay? In
Okay,
higher
sir.
classes, we learn about real numbers. Okay,
Thank you, sir.
Okay, very good. Right. Clear and understood about this one? Okay. Surya Prakash.
Sir, why write extensive of identity, sir? Additive of identity we can write no, sir.
What additive of identity? See once. Existence of inverse, existence of identity.
In our class, and additive identity is there, sir.
Okay, both are same. I will explain one by one. Okay.
And
When I will come to the existence of inverse, existence of identity, I will explain about that one.
Sir, we want to convert the unlike fractions into mixed fractions, no, sir?
Yes, not unlike fractions, improper fraction. Improper fraction can be changed into mixed fraction.
Yes, sir.
Yes, this is an improper fraction, 25 by 6. That can be changed into mixed fraction.
And
Okay,
why
boy?
rational numbers name into quotient numbers, sir?
Yes, rational numbers are also known as quotient numbers.
Why, sir?
Okay, very good. I will explain once. Just listen, Amma.
Okay.
Suppose, for example, we can take 20 by 4. 20 by 4. This is the rational number, no? This rational number is nothing but 20 divided by 4. Can we write?
Yes, sir.
Yes, 20 by 4 is nothing but 20 divided by 4. Means after doing the division, see here, 4 can how many times divisible by 20? 5 times now. 20 here, remainder 0. What is the result after completing the division?
0, sir.
Okay, after completing the division, result is quotient. Now we got the quotient.
Yes, sir.
Yes, after completing the division, we will get the result some quotient, no?
Yes, sir.
That's why rational numbers are also known as quotient numbers.
Okay, sir.
Very good. Clear, boy?
Okay, sir.
Okay, well done. Okay, Amma. Just listen once now. Again, addition. Here, closure property. First one, we are going to take first operation, addition. 2 by 3, 7 by 2. After adding these two rational numbers, we will get the result is also a rational number. Yes, 25 by 6 is an improper fraction. It can be changed into mixed fraction. This one, 25 by 6, 6 4 the 24. Here, one already you know in lower classes these all things. Now it can be write as 25 by 6 is equal to, here see, quotient plus remainder by divisor. See children once, here 25 by 6 can be written as quotient plus remainder by divisor. See here, it can be written as quotient how much? 4, remainder 1. So it can be written as 4, 1 by 6. Is nothing but can be written 4 plus 1 by 6. Like this also you can write 4, 1 by 6. Is nothing but 4 plus 1 by 6. Suppose this mixed fraction, again this mixed fraction again can be changed into improper fraction. We know. Here see, 6 4 jar 24. 24 plus 1, 25 by 6. Like this also we can write. Yes. An improper fraction can be changed into mixed fraction. A mixed fraction can be changed into an improper fraction. Yes, that's why. See children, now it can be write as 4 1 by 6. Here 4 1 by 6 means a whole number followed by a proper fraction. A whole number followed by a proper fraction. Here whole number proper fraction. Now we can take these two rational numbers from the set of rational numbers now. Again getting the result. This result now 4 1 by 6 is also belongs to the rational number. After getting this addition, we will get the result also a rational number. Do you understand? That's why rational numbers are closure property under addition. Rational numbers satisfy closure property under addition. Do you understand, children? Because of once again I will explain about this one. We can take any two rational numbers. Okay. After adding, we will get some result now. That result is also a rational number. Yes. At that time, those two numbers here, whatever we can take here, this set of numbers satisfy closure property under addition. Okay. Now it can be read as rational numbers are satisfy can say like this. Rational numbers satisfy closure property under addition. Rational numbers satisfy closure property under addition because of we can take any two rational numbers from the set of rational numbers. We can add the two rational numbers. After getting the result is also a rational number. That's why rational numbers satisfy closure property under addition. Do you understand, children? Take any rational numbers. Any rational number we can take and do like this addition. We will get the result also rational number. That's why that is the reason rational numbers satisfy closure property under addition. Clear? Yes. Now it can be read as for any two rational numbers. Just a small note about this one. For any two rational numbers A comma B, for any two rational numbers A comma B and A plus B also a rational number. For any two rational numbers A comma B and A plus B is also a rational number. So rational numbers satisfy closure property under addition. Just once again I will write this one. Here not visible to see in down. Okay, children. Okay, children. Just I will introduce two symbols for you. What about that one? First one is for all. This symbol is for all. Next one is for all or for every. For all or for every. This symbol is read as for all or for every. This means already I explained about yesterday. Belongs to. This is belongs to. Now just about this one I will use these symbols and write this one also. See, for all, you can write like this. For all A comma B belongs to Q. For all A comma B belongs to Q and A plus B belongs to Q. For all A comma B belongs to Q and A plus B belongs to Q. Yes, these two are rational numbers. After adding the operation first, addition operation A plus B, getting result is also a rational number. Yes, that's why rational number satisfy closure property under addition. Okay, rational number satisfy closure property under addition. The symbol means for all, means for every element of rational numbers. For these two elements taken from rational number, this means for every element of rational number. It means for every element of rational numbers. For all A comma B belongs to Q means rational numbers and A plus B belongs to Q. That is the reason rational numbers satisfy closure property under addition. Okay, children? Next. Okay, children. Just Renuka, any doubt? Surya Prakash, do you
Sir?
have any doubt?
Sir,
Yes, ask me, Amma. Surya Prakash.
this symbol, sir, are they like this symbol, sir?
Yes. Can I explain about that symbols?
Yes, sir.
Okay, very good. See, Amma, this symbol is known as, just you can write V and just cut off like this. It can be read as for all or for every. For all or for every. Means now we can take now A comma B belongs to Q. These two are elements of set Q. These two are elements of set Q. Means elements means numbers. Understood? After getting the result A plus B means after adding these two, first operation addition of A plus B, getting result is also a Q. Means it can be written as for all A comma B belongs to Q and A plus B belongs to Q. Yes, A comma B belongs to Q means A comma B are taking from the set Q and after adding this result is also belongs to that set only. That's why rational number satisfy closure property under addition. Yes,
Yes, sir.
very good. This means for all or for every. This is belongs to. Dinesh. Yes, Dinesh. Any doubt, boy? Dinesh. Yes. Asrita.
Sir,
Yes, ask me, any doubt?
please can we give examples for belongs to and for every all with numbers?
Yes, sure, Amma. Very good. See, once observe here. Suppose, for example, we can take n. N means set of natural numbers 1, 2, 3, 4, 5, so on so. These all are set of natural numbers now. Now we are going to take, suppose this property, first one is closure property. Just observe here. This is the closure property. First operation is addition. Just observe now. We can take any two natural numbers means 2, 3. 2, 3 belongs to n. Means we are taking from the set n now. That's why you can write like this: 2, 3 belongs to n. After adding these two numbers, 2 plus 3 is equal to 5. Result is also a natural number. So that's why we can write like this: 5 belongs to n. Okay, take two numbers from set n. After adding these two numbers, result is also a natural number. That is the reason natural numbers satisfy closure property under addition. Natural numbers satisfy closure property under addition. Simply it can be written as for all. For all means now I took now here a comma b means instead of a comma b we can take any number. Any number. A means any number from set n. B means any number from set n. That is the reason I can use this English alphabet a comma b in mathematically. Variables I am using here. For all a comma b belongs to n and result a plus b means some result definitely we will get. That is also a natural number here from this set. Yes. Okay. Take two numbers from natural number. We can add them. You will get one result that is also belongs to natural number. Understood? Now
Yes,
it can
sir.
be written symbolically for all a comma b belongs to n and a plus b belongs to n. That is the reason natural numbers satisfy closure property under addition. Closure property under addition. Yes.
Okay, sir.
Okay. Good. Dinesh.
Sir,
Yes. Ask me, Amma.
decimal form is also an closure property, sir.
Yes. Once again.
Decimal form is a form of a closure property, sir.
Decimal form.
Yes, sir.
Yes, decimal form means that is also changed into rational number now. Suppose for example, see here 0.2. Yes,
Yes, sir.
0.3. It can be written as 2 by 10. Okay, ma.
Yes, sir.
0.3 becomes nothing but 3 by 10 now.
Yes, sir.
And these two numbers we will get same denominator now here.
Yes, sir.
10. Here 2 plus 3 is equal to 5 by 10. Means 5 by 10 is nothing but 0.5 now.
Yes, sir.
Yes. So these numbers also satisfy closure property under addition.
Okay, sir.
Yes.
Okay, sir.
Very good. Now just I will write one point about closure property. Note down. Valli, ask me, Amma.
Sir,
Yes.
give me another example for this one, sir.
Yes, sure, I will give.
Okay, sir.
Suppose 1.25 and 6.25 we can take these two rational numbers, these two decimal numbers like this. Can be written as 125 by 100. We know already point after 2 digits there. So can be written 125 by 100. Already in lower classes we learn about these things, how to change decimals into p by q form. Here remove the decimal point and write this. Okay. See, after adding these two, we will get here. See, same denominator, no, 100, 100, 125 plus 625 means can be write as 0, 5, 7 by 100. Now 0, 0 cancel. 75 by 10 means 7.5 can write like this. After getting result is also decimal now. These two are decimal numbers. After getting result also decimal number. Yes, this decimal number is nothing but this is also rational number. Understood? So these numbers also satisfy closure property under addition.
Sir.
Right? Ah, yes.
So
Surya Prakash?
use symbols to write rational numbers, sir.
Hello, ask me.
Sir, in simple form, we use symbols to write rational numbers, sir.
Once again, Amma, not visible problem. Once again, ask me.
Sir, the symbols to write the
Hello?
rational numbers in simple form.
Ask me, Amma, once again.
Sir,
Yes.
so in simple form, we use symbols to write rational numbers, sir.
Ah, yes.
Okay, sir.
Once again, ask me, Amma, question not clearly. I am.
In simple form, we use symbols to write rational numbers, sir.
Ah, yes. Means.
Symbols.
Yes, like this also we can use.
Symbols.
Hello.
In simple form, we use symbols to write rational numbers, sir.
Ah, yes.
Okay, sir.
Okay, about closure property under addition, write one point, children. For every rational number, A comma B and time. See children once A and B are any two rational numbers A comma B are any two rational numbers. If A comma B are any two rational numbers, then A plus B is also a rational number. Note down children this point. If A and B are any two rational numbers, then A plus B is also a rational number. That is the reason. So, rational numbers satisfy closure property under addition. Rational numbers satisfy closure property under addition. Closure property under addition. Now it can be read for all A comma B belongs to Q and A plus B belongs to Q. Just we can write like this. Write down, children. Children, we will meet again next class on Sunday. Thank you.